Given that I is a complex root of this quartic polynomial, find A. Hence, or otherwise, find the remaining roots. So first of all, given that I is a complex root, that means that f of I is equal to 0. That's what we mean by a root. It means that when we substitute I in, we get 0. So what that means is that I to the power of 4 minus 2i cubed plus 6i squared plus ai plus 5 is equal to 0. Simplifying, I to the power of 4 is 1. I cubed is minus I, so this becomes plus 2i. I squared is negative 1, so minus 6. ai is just going to be a times I, plus 5 is equal to 0. The 1, the minus 6, and the 5 cancel out, so we just get left with 2i plus ai are equal to 0, which means a must be equal to negative 2. There are other ways you could go about that. That's probably the most straightforward, but not necessarily the most obvious. Now, by the conjugate root theorem, we know that minus I is also a root. The conjugate of I is minus I, so minus I is also a root. That means that we can rewrite f of x as x minus I, x minus negative I, which is x plus I, and then times some quadratic. It's got to be x squared to give me x to the power of 4. And then I've got to fill in the other bits of this quadratic. So what are the other bits going to be? Well, before I fill in the rest of this, I'm going to expand this to get x squared plus 1, which makes it a bit easier to fill this in. Now I know the constant term is plus 5. I have plus 1 here, so this needs to be plus 5. And then currently I've got 1x squared. I need 6x squareds. So I've got 1x squared and 5x squareds, which gives me my x squareds. How many x's have I got? I've got no x's. So 1 times this has to give me the number of x's. I have minus 2 x's, so this has to be minus 2x. I also need minus 2x cubes, which I get by doing x squared times by minus 2x. So now I've factorized this into 2 linear terms and a quadratic, but that quadratic can also be factorized, but not with integers. It can be factorized into using the quadratic formula. So just looking at this quadratic, now we get x is equal to minus b, so 2 plus or minus the square root of 4 minus 4 times 1 times 5 all over 2, which is 2 plus or minus the square root of 4 minus 20, so minus 16 over 2. So that means we're dealing with complex roots. So we've got 2 plus or minus the square root of 16 is going to simplify down to 4i over 2, which is 1 plus or minus 2i. That means our roots, just to make it very clear at the end, our roots are, we had I that we were given, the conjugate of that is minus I, 1 plus 2i, and the conjugate of that is 1 minus 2i. So we have 4 complex roots here for this particular quartic. There are no real roots. What that means is the graph of this quartic never crosses the x-axis, so maybe it does something like this. Never crosses the x-axis, but it does still have 4 roots. They're just all complex roots.